Alright, welcome to the video on the law of cosines. Alright, so let's derive the law of cosines real quick. Alright, so we've got this triangle, an oblique triangle. Alright, so this distance here from B to C is A, so that makes this point right here, A comma 0. Alright, so then we're going to make this right triangle. We're going to drop down a line here, make a right triangle. And we're going to call this distance right here X, and this distance right here Y. Right, which means that this point right here where A is located at is X comma Y. Alright, so now let's go off here to the side and say, if we've got this right triangle here, right, and this is angle B, then the sine of B is equal to Y over C. Opposite over hypotenuse, the hypotenuse being C here. And then the cosine of B would be X over C, because adjacent over the hypotenuse. Everybody see that? So that's going to imply that Y is equal to C sine B, and X is equal to C cosine B. Alright, so now point A up here is really C cosine B, comma C sine B. Everybody see that? Because X is C cosine B, Y is C sine B. Alright, so that's this point right here. Just written in a different form. Okay, so now we've got these 2 points, A comma 0 and C cosine B, C sine B. So now we can figure out what the distance of B is, right? So B is equal to the square root. Alright, so what do we got? We've got C cosine B minus A squared. Right, that'd be x1 minus x2 squared plus C sine B minus 0 squared. Okay, for the y1 minus y2 squared. Just the distance formula is all we've got there. Right, so then that gives us, if we square both sides, we get B squared. Now let's multiply out this C cosine B minus A. So that's going to give us all of this that I just wrote right here is this C cosine B minus A quantity squared when you just FOIL it out. Then we have a plus. This thing over here is just C sine B, and so then we're squaring that. We get C squared times the sine squared of B. Alright? So that's just a bunch of algebra. Alright, so then that means then B squared is equal to A squared plus, let's see, with these two things right here that have C squared. So we could take a C squared out, and that leaves cosine squared B plus sine squared B. And then we have minus 2AC cosine B. So all we did was just group the C squared cosine B and the C squared sine squared B and factor the C squared out. And why did we do that? Because cosine squared B plus sine squared B just goes to what? That's right, it just goes to 1. So B squared is equal to A squared plus C squared times 1, which is just C squared, then minus 2AC times the cosine of B. And that is one form of the law of cosines. Alright, so notice what we have here. We have the cosine of some angle. The side opposite that angle is what's being squared over here on the other side of the equal sign. Then all the other parts, the A squared, the C squared, and the 2AC, those A's and C's, those are really just the other two sides of the triangle, right? The angle B is between these two sides, the A and the C. Everybody see that? I mention that because we can generalize up the law of cosines as such. In any triangle ABC with sides A, B, and C, essentially all three of these things are true, right? But I don't want you to think about it in terms of, oh, I've got 3 formulas to memorize. That's not really true. If you understand the idea, then there's not really any formula to memorize. So the idea is we have some side squared is equal to one of the other sides squared plus the third side squared minus 2 times those other 2 sides times the cosine of the angle opposite the original side you started with. It's the same for all of them, right? This C is the angle opposite this side over here, this little c. and then these other parts are just the other two sides of the triangle. Okay? Alright, so here's an example. Alright, we want to solve this triangle. We know, and this is for side angle sides. We know a side, we know an angle, and we know the next side. Alright, so we know that A is 121 degrees, side B is 5, and side C is 3. Alright, so we want to figure out this side, little a. Alright, so a squared equals, so the sum of the squares of the other two sides, so 5 squared plus 3 squared minus 2 times 5 times 3 times the cosine of your angle A, which in this case is 121 degrees. All this mess on the right hand side you just do with the calculator, and that gets you down to a squared equals 49.5411 when we approximate, and so A is about equal to 7.03. Alright, so 7.03 is A. Alright, once we know that, now we can go figure out angle B or angle C. And how do you think we're going to do that? Well, we're going to use the law of sines. So now use the law of sines, and we'll have 7.03 over the sine of 121 degrees is equal to 5 over the sine of B. That implies that the sine of B is going to be equal to 0.6095. When you isolate the sine of B, and that means that B is equal to 37.6 degrees. All right, so now we know what angle B is. 37.6 degrees. So now that we know angle A and angle B, we can get angle C, which would be 21.4 degrees. And now we've got all 6 parts of the triangle. Alright, so let's look at one more. Alright, this time we're going to have side, side, side triangles. We know all 3 sides. Now, be careful. When you know all 3 sides of a triangle, to figure out the angles, make note, find the largest angle first. So looking at A, B, and C, how would you even know which one would be the largest angle? Well, remember, the largest angle is the angle that's opposite the largest side. Right? So since 19 here is the largest side, B, angle B here, has to be the largest angle. Right? So we want to find that one first. So using the law of cosines, we have 19 squared equals 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of B. Right? So do the math on that, isolate cosine B, and you get cosine B is about equal to negative 0.45089. So use your calculator and you'll get B to be equal to 116.8 degrees. Notice there's only one B to find. That's because the other angle where the cosine of it is negative would be in the third quadrant, and that's more than 180 degrees, and so therefore it can't be an angle in a triangle anyway, right? Right. So figure out. Let's figure out A. Sine of A divided by 8 equals the sine of 116.8 degrees divided by 19. That implies that the sine of A is about equal to 0.3758, which implies that A is about equal to 22.1 degrees. And as soon as you know A and B, we can figure out C by subtracting them from 180. So that gives us 41.1 degrees. And that's it. We solved that triangle. All right, so that's the idea on the law of cosines. All right, study well. Please let me know if you have any questions.